Height of our image is 71 pixels. The next power of 2 value that could handle that is 128. So our actual texture size that has been created by Texture 2D is 64 pixels wide by 128 pixels deep. And that's important. We need to know the size of that new image, if you like, for our calculations. And that's what's being stored inside the image width and the image height. I have a bit of a cold, so excuse me if I if I cough or sneeze through this. The next things we have are texture width and texture height. So I've just described that our image width and our image height could be larger than the actual texture inside it that we want to display. So the texture is actually held as a number from 0 to 1. So 0 being the left-hand side of the texture, 1 being the furthest right-hand side of the texture, and it's the same for the height. So if we had an image size that was 128 by 128, but our texture, the actual image we wanted to display, was only 64 by 64, then it would mean that our texture width would actually be 0.5. In other words, it's halfway across the entire texture. So the whole texture is 128 wide. Our texture is only 64 wide, so getting access to the right hand side of it would be a value in texture width or texels of 0.5. Same for the height. Again, that's going to be handy for us to hold that so that we can actually, for an image, when we render the image, we can have very easily specified exactly where we want that image to be taken from our larger texture. So texture width and texture height are going to be doing that. We then have our max texture width and our max texture height, and this is important because, as I said, 1 is the furthest right hand side of our image, but if our image isn't that big, it's only 64 pixels wide, something like that, we want to know, well, what's the maximum texture width that we can have, which would be 0.5 in that instance. So we're going to store those as well. We then have something called the texture width and the texture height ratio. And these are just values that are calculated and that we can use later on. So if we know that the width of our image is 128 pixels, we can then say 1 divided by 128 gives us a ratio. So it tells us how many real pixels we need to, or how many real pixels are, let me just describe this, I'm not describing this very well. If we have 0 to 1 is the texels, okay, 1 being the right hand side, we need to understand how many texels relate to how many pixels on the screen. So what 1 pixel in our image relates to 1 texel in our image. So that's what we need the ratio for. And that means that we can do the width of the image divided by 1, and that gives us our ratio. So we can use that. If we want to get 50 pixels across in our texture, we can say 50 multiplied by the texture width ratio, and that will give us our texel value in how far we need to come across the image. So again, they are useful values to have inside our image to actually be able to really specify where we want to print things out. I've then created something called a texture offset for X and Y. And again, we may have a texture in our image that is a large texture, but this particular image actually is only going to be referring and printing a small part of it. So being able to set an offset on the X and the Y axes, and then just saying, you know, print the image this wide and this high from that offset is a useful thing to be able to do. It's going to speed up when we're actually rendering our image to the screen, in terms of we're not going to have to do the complicated calculations ourselves. So that's in there, and these things will probably make more sense as we actually start to use them. We also have at the end here rotation. So I want to be able to store the number of degrees of rotation that should be applied to the image. We have scale. I also want to be able to store the scale of the image. I want to be able to scale it up using a positive float value, and I want to be able to scale down using a negative float value. And I also want to be able to apply a color filter. In other words, I want to be able to apply a color to the image as it's displayed using red, green, blue, and alpha. And to do that, I'm using a float array with 4 possible locations: 1 for red, 1 for green, 1 for blue, 1 for alpha. So that really sets up quite nicely our properties that we need when we're actually dealing with an image. So once we've set those up, we then need to apply all of the necessary getters and setters for those particular properties, which is what I'm going to add now. Excuse me. which is what I'm going to actually stick in here now. So if I pop the getters and setters in. Okay, so this is really straightforward. We would have seen this before. Some of these are actually marked as read only. So the texture width and the texture width ratio, they are calculated when we create our image, and we don't really want to change those because we're not going to let an image has a reference to a texture, and we're not going to let that change. If you want a different one, you create a new image. So these things we can read them, but we can't actually change them. The others we're just doing getter and setter, so we can get and set the rotation, the scale. We can actually get and set the image height and the image width. And again, in fact, image width and image height are probably things that that we need to say are read only. So I'm actually going to just stick in read only here. Okay, because they are defined during the initiation of the image and won't get changed by any external software as we go through. Okay, now one thing I do want to add to the top here are some notes, some comments that I've created. And what I'm trying to do with these comments is just give you something to be able to read and understand a little bit more about how texture mapping works and how the textures are mapped. So if I paste in this rather large comment area here, okay, and my little picture here has sort of not worked quite as planned. So let me just move these in a bit. So this is just this was just a little diagram here to try and show what the important things were inside my. Okay, here we go. This was really just to try and show what I was talking about earlier in terms of what pixels relate to what items inside an image when it comes to the texture and so forth. Okay, so that's looking a bit better. Okay, that's a little bit better there. So what this little diagram here is saying is that we may have, and I'm using my my player.png picture as an example. Okay, so the player.png picture was actually 48 pixels wide by 71 pixels high. And that actually, because of the power of 2 rule, meant that we ended up with an image being created, or a texture being created by Texture 2D that is 64 pixels wide and 128 pixels high. So that's our texture width and that's our texture height as we've defined in our properties. Our image width is the actual width of the image itself that is inside there. Okay, so the texture width is the width and the height of the texture. The image width and height is the width and height of our actual image inside that texture. As you can see, it's not taking up all of the space that has been created in that texture. Because of this, you do have to think carefully about your graphics and about how you use them. You don't want to waste too much texture memory by having unused space like this, which is really where sprite maps and texture atlases are important, because you could end up having this image plus maybe another image underneath it and maybe a set of images down here. And you could use those and reference those as you need to inside a single image. So those sub-images inside a single image mean that you're making best use of these spaces. So you're packing together a number of different images in a single image, and then you're going to reference them as sub-images later on. So if we can reference them as sub-images, we can then save quite a bit of texture space by packing them all together. There are tools out there that actually let you pack images together and give you like a little control file